Hello class. Today we're going to do lesson 6.5, which is on understanding like terms. Alright, so I'm going to read this paragraph for you. It says, the Roberts family was having a reunion at a local park. They made signs and t-shirts. The Robertson family was also having a reunion at the same park. Their last names were so similar that the lady at the park gate started to get confused as to which pavilion to send each family member. Yet, just because the last names sound so similar, it's clear that the ending of the last names are different. So I'm going to stop right here for a second before we go on to the last sentence, or the last two sentences. So what that was saying was that we have this family called the Roberts and the Robertson. Now, they are a different family. They do not have the same last name, okay? The Roberts family, the one on the left, was having some family picnic at one of the pavilions. A pavilion is like one of those little, I'm not even going to attempt to draw it, like at a park, like a shelter at a park, okay? So they were having a picnic at one spot. The Robertsons were having a picnic at another spot. Now, thinking about families, right? These two families are not the same. They're different, okay? Now, I'm going to go back up here. The last two sentences say, the same is true of polynomial terms like xy and xy squared. They look very similar, but they are not like terms. So let's say I had an xy and an xy squared. These two are different and they are not the same, so we can't combine them. Just like family members, right? Even though Roberts and Robertson look very similar, they're not the same families. All right, if I scroll down, like terms is our first vocab word. What that means is terms that have the same variable parts. So when we were mentioning xy and xy squared are not like terms because they look a little bit different. The part that looks different is that this one has a little squared in it. That makes them different. Okay, so like terms have to have both the variables and the exponents must be the same. All constants are considered like terms. So what that means is like 2 and 7, right? Those two would be like terms. 2 and 7 because they're just a constant, just a plain number. Okay, taking a look at this green box of examples, I'll zoom in. All right, we have negative 5n to the third and 8n to the third. What makes them like terms is this n to the third. The number in front, the coefficient, that doesn't have to be the same, but the variable part has to be the same. In this next one, 4abc and 8abc, the reason these are both like terms is because they both have abc. 20 and negative 13, they're just plain numbers, constants, so they're like terms. And then this one, 4xyz to the third. This looks crazy, but xyz to the third is the same as xyz to the third. Now, if there was a little exponent like right after the x, then they would not be like terms. Okay, so they have to have the exact same letters there. I noticed that this one has a 4 and this one doesn't have anything in front. Again, then the coefficient, the number in front, doesn't matter what that is as long as the variable part is the same. Okay, and if you remember, if there is no number in front of a variable, that's our hidden number of 1. Okay, going on to example 1. Identify the like terms in the following expression. All right, so I'm just going to go ahead and I'm going to circle 8y. And now I'm going to look at negative 7 and 2y. Do any of them have a y in it? Well, 2y does. So I'm going to circle that. And I'm actually going to do a little trick here. I circled even this plus. I included that as part of the thing that I circled. The reason why is because that indicates that this is a positive 2y, okay? Where in contrary, this 7, it's a negative 7 because of that minus sign. So negative 7 is different. It doesn't have the y with it. So our like terms, we have to identify the like terms. We have 8y and 2y are our like terms. Those are the two things that look the same. Going on to letter B, I'm going to go ahead and I'm gonna underline the constants. That's what I typically do, is I underline any of the constants or the plain numbers, the numbers that do not have a variable with them. So 7 and negative 2 are the only two up there that don't have a variable with them. Okay, I'm going to go ahead and I'm going to circle this negative 5h. And again, I'm going to include the plus or minus that's in front of it. So this one just happens to be a minus. That makes it a negative 5h. And then over to the right, we have negative k, or negative 1k. All right, and that looks different than the h. So that means they are not like terms. Okay, they are not like terms because the h and the k are not the same. All right, looking at letter C. Okay, I'm going to go through and I'm going to underline the plain numbers, the constants. So we've got plus 15, we've got a negative 3, and those are the only two. So I'm going to write them down. 15 and negative 3. Now I know that it's positive 15 because there's a plus in front of the 15. All right, I'll circle the ones that have the k in them. So that one, this one, it doesn't have a k. This one doesn't have a k. This one doesn't have a k. So we're done with that. I will box the m's. So this one has an m. Okay, that's the only one that doesn't have an m. Let's see. How about I will triangle the ends. So that one and the last one isn't a triangle. Okay, I'll do a different color here. I'm running out of color options. All right, then negative 7p, that one is also different. So the only two like terms were the 15 and negative 3. All right, moving on to letter D. I'm going to underline the constants, the plain numbers, including like the plus or a minus that's in front of it. Okay, so we have 3 like terms there. We have negative 8, we have positive 7, and we have negative 2. Those are all like terms. Okay, I'll go ahead and circle the ones with the C. And again, I'm circling in front there, that negative or the plus, I'm including that. Okay, good. So those are all of them. We've got negative 4c, we've got negative c, and we've got negative 12c. So this is a set of like terms, and this is a set of like terms. All right, we have 2 more. No backside on our notes today. So letter E. Okay, I'll go ahead and I'll underline the constants, the number that's by itself, and it looks like it's just 5. I will circle anything that has an A with it, including that negative or plus in front of it. So we have 2A, negative A, and 6A. Those are a set of like terms. One more question, letter F. I'm going to go ahead and I'm going to underline the constant or the plain number, including that positive or negative in front of it. So we have a 14 and we have a negative 2. Okay, now I'm going to circle anything with an X. Now, I would not circle this negative 3y. The reason is because it has a y and not an x. I was going to circle all the x terms. So we've got a 7x and a 3x. And then I will box in the ones with the y. And there is not another y term, so that means that there are no like terms with the y. Okay, that was our notes for today. Thank you so much